Good morning, students. Chapter 4, Moving Charges and Magnetism. Yes, in last lecture we have discussed about torque acting on rectangular loop. Okay, and yes, at last we have proved K I into A. It is called magnetic moment. It is called magnetic moment. So yes, here we will clear about that. See, current loop as a magnetic dipole, circular current loop as a magnetic dipole. See, you know one case, that is, if it is circular loop, current of point is I, its center, axis, its radius is R, on axis from center at distance x, at this point, what is equation of magnetic field? See, on axis at distance x, magnetic field, B is equal to, what is equation? Mu 0 I r square upon 2 r square plus x square raised to 3 by 2. Yes, here I am taking number of terms. N is equal to 1. But your equation is mu 0 ni r square upon 2 r square plus x square raised to 3 by 2. Clear about this? Yes, you know this equation. Yes, you know this equation. Yes or no? Yes, it is. Yes, it is. Okay. Yes, x center. How to find magnetic field? Put value of x is equal to 0. Then you will get mu 0 I upon 2r. Obviously, I am here taking x is very greater than r. X is very greater than r. Means this point is at large distance comparative to its radius. Or I can say that this circular current loop is small. Circular current loop is small. X is very greater than r. Means point is away from center. Or you can say loop is small. Then what you have to do in this denominator with respect to this x, you have to ignore, you have to neglect this r. Okay, then how to write equation? See, B is equal to numerator as it is mu 0 I r square divided by 2 as it is. X is very greater than r, so put this r is equal to 0, then you will get x square raised to 3 by 2. X square raised to 3 by 2. Clear about this? Okay. Is equal. It is mu 0 I r square divided by 2. X square raised to 3 by 2. Square and 1 by 2 cut. So yes, it is only x cube. Yes, you know this. Okay, now see what I will do here. Here is equal to mu 0 I r square divided by 2 x cube. I am multiplying by 2 by and dividing 2. Clear about this? Okay, now I will rearrange this equation as, see, I will rearrange this equation as B is equal to, here it is, mu 0, 2 into 2 pi, here it is 4 pi. And okay, I pi r square, here it is pi r square, divided by, here it is x cube, and yes, this 2 is here. See each and every term, mu 0, 2 pi into 2, 4 pi, 2, here it is I, here it is pi r square divided by x cube. What is radius of circular loop? R. And what is its area? Pi r square. And yes, I can write this pi r square as its area. So B is equal to mu 0 upon 4 pi 2 I pi r square means A divided by x cube. Yes, in the last lecture we have discussed IA is equal to magnetic moment. So B is equal to mu 0 upon 4 pi 2m upon x cube. B is equal to mu 0 upon 4 pi 2m upon x cube. It is magnetic field on axis. Clear about this? Clear about this? Okay. Now remember chapter number 1, electric fields and electric charges. Okay. Remember case of electric dipole. Remember electric field on axis of dipole for short dipole. Or we have considered one case. Okay. For short dipole. For short dipole. If you remember equation of electric field, E is equal to, it is 1 upon 4 pi epsilon 0, electric field on axis, 1 upon 4 pi epsilon 0, 2p upon r cube. Yes or no? 2p upon r cube. Yes, it is equation for short electric dipole. Yes, I will here write electric dipole. Okay, then yes, it is equation of electric dipole. Okay, on axis is electric field 1 upon 4 pi epsilon 0, 2p upon r cube. Now see here, for electric dipole, when r is very greater than a, we have obtained this equation. Remember, okay, here x is very greater than r. See, observe these two equations. Magnetic field on axis, electric field on axis is equal to 1 upon 4 pi epsilon 0 constant, mu 0 upon 4 pi constant, 2 p electric dipole moment, m magnetic moment, r distance q, x distance q. Clear about this? Clear about this? Then yes, here how to compare this magnetic field with this electric field. How to compare? See, in electrostatics, and here it is in magnetism. Here it is in magnetism. Electrostatics, electric field, E. Here magnetism, you have to write magnetic field. E. Clear about this? Okay. Another comparison of constant for constant. In electrostatic, which constant is used? 1 upon 4 pi epsilon 0. Here which constant is used? Mu 0 upon 4 pi. So see 4 pi, then you can also write mu 0, 1 upon epsilon 0. Yes, mu 0, 1 upon epsilon 0. Comparison, okay. Third one is, yes, here electric dipole moment, P. Here magnetic moment, yes, magnetic moment, M. Yes, what is equation of magnetic moment? It is IA. For n turns, what is magnetic moment? M is equal to NIA. M is equal to NI. Clear about this? How to find direction of magnetic moment? See here, in this wire, wrap your fingers in direction of current. Thumb indicates direction of magnetic moment. Okay, wrap fingers of right hand in direction of current. Thumb gives direction of magnetic moment. Clear about this? So yes, it is one comparison that indicates current carrying circular loop as a magnetic dipole. Clear about this? Why this title is given? See, for circular current loop, we have obtained this equation, and this equation is equivalent to for short electric dipole. So yes, from these equations you can observe. Okay, it is similar to electric dipole. Then yes, we can say magnetic field due to magnetic dipole. Clear about this? So yes, circular current carrying loop behaves as a magnetic dipole. Having magnetic dipole, M is equal to NIA. N numbers of turns, I current, and A is area. Clear about this? Okay. Example 4.11. See, you are given a circular coin having number of turns 100, radius 10 cm means 0.1 meter, carrying current I is equal to 3.2 ampere. Question A. What is magnetic field at center? What is magnetic field at center? Yes, you know what is equation of magnetic field at center. PC is equal to mu 0 Ni upon 2r. B is equal to mu 0 Ni upon 2r. Mu 0 4 pi 10 raised to minus 7. And what is value of n? 100. R, yes, sorry, I, it is 3.2. 2, yes, it is 2. R means it is radius, it is 0.1. Clear about this? Clear about this? Then yes, you have to solve this. Yes, you have to solve this. If you solve this, you will get your answer nearly. It is 2 into 10 raised to minus 3. Yes. Question B. Question B. What is magnetic moment? Yes, magnetic moment. Magnetic moment, its equation M is equal to NIE is equal to NI. A means pi r square. Okay, and 100. What is value of I? 3.2. What is pi? 3.14. What is value of R? It is 0.1 whole square. Clear about this? Okay, so yes is equal to, if you multiply this, you will get momentum nearly 10. You will get momentum nearly 10. Okay, yes, what is unit of momentum? N numbers of turn, unitless. I, current, so its unit is ampere. A, area, its unit is meter square. Simple. Okay, question C. Question C. When this circular coil is rotated in uniform magnetic field, B is equal to 2 Tesla. See, this magnetic field is produced due to current. Now this coil is placed in some external magnetic field, uniform magnetic field, B is equal to 2 Tesla, and it is rotated at angle theta is equal to 90 with magnetic field. Then your question is, what is torque acting on it? What is torque acting on it? Okay? Okay? What is question? Question is, this loop is rotated at angle theta. Then you have to find torque. What is equation of torque? Torque is equal to this NB sine theta. So is equal to this NB sine 90. What is value of sine 90? What is value of sine 90? Yes, sine 90 is equal to this. Sine 90 is equal to this one. But see, what is question? It is rotated in magnetic field such that its loop makes angle 90. Its loop makes angle 90, means like this. See, if it is magnetic field and loop makes angle 90, this loop makes angle 90. Okay, so current, for example, it is going in this direction. It is direction of magnetic field. See carefully. See carefully. Tau is equal to mb sine theta. Theta is angle between M and B. Theta is angle between M and B. Theta is angle, it is rotated by 90 degree. It is rotated by 90 degree. Okay, initially loop is in direction of magnetic field. Then it is rotated by 90 degree. Then what happens? See, as current is going in this direction, wrap fingers in direction of current. This thumb indicates direction of magnetic moment. Clear about this? Then see, this P and N, they are in same direction. So tau is equal to, here it is NB sine 0. So therefore torque is equal to 0. Clear about this? Understand this data again. Initially loop is parallel to magnetic field, then it is rotated by 90 degree. Then tau is equal to NB sine theta. Theta is angle between M and B. How to find direction of M? Wrap your fingers in direction of current, thumb gives direction of magnetic moment. Okay. Now, question D. Question D. What is angular speed acquired when rotated 90 degree while moment of inertia is 0.1 kg meter square? You have to find what angular speed acquired, omega, angular speed. See how to find. We know equation of torque. Tau is equal to mb sine theta. Tau is equal to mb sine theta. We have to find omega. How to find omega angular speed? See, remember 11, chapter number 7, torque, its equation I alpha. is equal to mv sin theta, where this m is moment of inertia. This m is moment of inertia. So remember about this. Okay, this I is moment of inertia. What is alpha? Alpha is angular acceleration. Alpha is angular acceleration. Clear about this? Okay, so now how to write this? See, I moment of inertia as this. Alpha angular acceleration, if you know, I can write this as d omega upon dt is equal to, here it is, mv sin theta. Clear about this? Now, left hand side, d omega upon dt, I can write like this. See, d omega divided by dt. I am dividing by d theta and multiplying by d theta. Clear about this? Okay. Then I d theta upon, yes, d omega upon d theta. D theta upon d means it is omega. Clear about this? Right hand side as it is. Right hand side as it is mv sin theta. Okay, so yes, if now here I write like this, I omega d omega is equal to mv sin theta d theta. Mv sin theta d theta. Clear about this? So what is meaning of this? If change in angle is d theta, then change in angular speed is d omega, and the relation between them is this equation. Okay, now I will integrate this equation both sides. I omega d omega is equal to integration mv sin theta d theta. I is constant, so out of integration I integration omega d omega. Clear about this? Is equal to this side mv constant out of integration sin theta, here it is sin theta d theta. Clear about this? Okay, now see this side, integration is with respect to omega angular speed. Initially, when it is not rotated, its initial velocity is 0, so 0, and final velocity we have to find. Initially, it makes angle 0, then it is rotated at angle by. Clear? Now integration, I as it is, what is omega d omega? Yes, you know it is omega square by 2, limit is from 0 to omega. This side, md as it is, what is integration of sin theta? It is minus cos theta, limit is from 0 to pi by 2. Now put limit, I, it is omega square by 2. Yes or no? Yes or no? Yes it is. I omega square by 2. Okay, minus 0. This side, it is mb. This side, it is mb minus cos pi by 2. Minus cos pi by 2. Minus minus will become plus cos c. Clear about this? Okay, now this side is I omega square by 2. This side it is mb cos pi by 2. Yes, it is 0, and cos 0 is equal to it is 1. So yes, here the answer is 1. Clear about this? You have to find this omega. So make this omega square as subject. Omega square is equal to 2 mb upon I. Okay, so omega is equal to under root 2 mb upon I. Now values, see, values is equal to under root 2. M means magnetic moment. What is magnetic moment? From equation number 8 is 10. What is B? B means external magnetic field, which is given. Yes, here it is 2 Tesla. So yes, here it is 2 Tesla. Divided by, yes, divided by I means, see, I means not current. Here it is moment of inertia, and you are given moment of inertia 0.1. Yes, it is 0.1. Yes, it is 0.1. Clear about this? Okay, so yes, how to simplify this? 0.1 means it is 1 upon 10, so it is under root 2 into 2, 4, it is 400, and its square root is 20. Its square root is 20. Clear about this? So yes, this question D, yes, this question D is important. What you have to do? Clear about this? But the question A, B, C, they are simple. Yes, this thing is important. Okay, see, it is rotated such that its plane makes angle 90 with magnetic field. So what is angle between B and M? It is 0. So that's why thought A is 0. Clear about this? So yes, in today's lecture we have discussed about circular current carrying loop as magnetic moment, how to find magnetic moment and angular speed. Okay.